Hi, welcome back to Musa Chemistry. This is the Broghe wave equation of extreme fun lesson number 2. The Broghe wave equation is used to prove the wave-like particle nature of light. We use the equation that lambda equals h over mv. Lambda is wavelength. H is Planck's constant, which is 6.626 times 10 negative 34 joules per second. M is mass of electron, 9.109 times 10 negative 31 kilograms. M could also be the mass of the proton, 1.67 times 10 negative 27 kilograms. And V is velocity of light, which is 3.0 times 10 to 8 meters per second. Okay, let's look at the first question. If an electron has a wavelength of 3.19 times 10 to 12 meters, what is the percent of light it is traveling at? Okay, so now what do we know? Okay, we know the wavelength. So the wavelength is going to be 3.19 times 10 to the negative 12 meters. Okay. We know that Planck's constant is going to be, of course, 6.626 times 10 to the negative 34 joules per second. We know the mass of the electron, which is 9.109 actually, times 10 to the negative 31 kilograms. Some people also use 9.11. And let's see, we're looking for the velocity of light, percent. Okay, so let's isolate this for V to start with, okay? So to isolate this for V, we would do lambda equals h over mv. So mv lambda equals h, v equals h over m lambda. So all I did was just move the equation around, right? Okay, well, let's do this then. Okay, so what we're going to do is we're going to say v equals 6.626 times 10 to the negative 34 joules per second over the mass, alright, which would be, of course, 9.109 times 10 to the negative 31 kilograms times, of course, our wavelength, which is 3.19 times 10 to the negative 12 meters. Okay. So then by the time we get all this said and done, this is going to give us, of course, V equals 6.626 times 10 to the negative 34. Let's make that 34 a little bit better. That looks like a 9. Sorry about that. Sometimes when we try to write this stuff small, the 4s don't work out very well. This, of course, this will be joules per second, and this is going to be over 2.90609 times 10 to the negative 42. Okay, so we've got to make this 4 look good. There you go. And of course, this is going to be kilograms times meters. Yeah. There you go. So V is going to equal 228,003 950.3, and this of course would be meters per second. So my question now is, what is the percent of light? So to do that, you take the percent of light. So I'm going to say percent of light is going to be equal to 228,003,950.3 divided by the speed of light, of course, which is 300 million meters per second. And that's going to give me light. And we have to make this times 100, of course. It's going to give me 76% the speed of light. So that electron is traveling at 76% the speed of light. Pretty simple, yeah. So let's look at the next one. What is the wavelength of a proton whose velocity is 59% the speed of light? All right, so now we're looking for wavelength in this case. So we're going to go ahead and, of course, we're going to use lambda equals h over mv. So what do we know? Well, we know h. H is Planck's constant. That doesn't change. Again, that 4 did not work out very well, so let me try that again. There you go. That's much better. And then we know the mass of the proton. Okay. So we know the velocity, and we're looking for lambda. So the velocity is 59% the speed of light. Well, you know the speed of light is 300 million meters per second, right? So this is easy to figure out. You times that by 0.59. And when you do that, that gives you this number, right? 77 meters per second. There you go. So now we have that for our velocity. And we are looking for lambda. Okay, well, this is pretty simple. Lambda equals, of course, Planck's constant. Okay, so far so easy. Over this. So we're going to do the mass of the proton. This is really not that hard. I mean, it doesn't look bad. It looks pretty darn easy, actually. Hope that sea turtle is enjoying his wave. Yeah, the Broghe wave. I know, okay. Bit of a stretch, but I thought you guys might like it. Okay, so this is going to give us this relationship. We're almost there. Again. Anytime I see a 4, when I try to write these things small, I kind of like going, ugh. Okay, so this is going to give me 2.9559 times 10 to the negative 19. And this, of course, was kilograms times meters times second, which is basically seconds will cancel out. Okay, we know that. Joules and kilogram will max out, and the wavelength is actually going to be 2.24 times 10 to the negative 15 meters. And that's your answer. Well, listen, you guys be snarly, and we'll see you back here at Musin Chemistry.